Hi friends, good morning. Welcome to the ASTRA 2022 program presented by AKKA IAS Academy. In this video, I'll be explaining 7 questions based upon pipes and cisterns. In the previous video, I have explained the basic concepts and formulas what you need to know before solving or before dealing with the pipes and cisterns problems. Okay, so let's begin. The first question is, there are two taps, tap A and tap B, to fill up a water tank. The tank can be filled in 40 minutes if both taps are on. Okay, tap A and tap B, if both are on, then the tank will be filled in 40 minutes. The same tank can be filled in 60 minutes if tap A alone is on. How much time will tap B alone take to fill the same tank? I will solve it in the next page. See friends, what they have given here is, there are two taps A and B. Okay, there are two taps A and B. If both are open, then the total time taken to fill the tank is 40 minutes. Okay, if A alone is opened, then it will be filled in 60 minutes. If tap A alone is open, then the time taken is 60 minutes here. They have asked to find out the time taken by tap B when alone it's opened. Okay, so there are two methods to solve the solve this problem. One is formula method, another is the conventional method. The formula method will be in the previous video. If at all you have watched the video, I request you to watch the previous video where I have discussed the formulas. Okay, so what's the formula here? M into N by M plus N. What is this? Total time taken, T here. So what is M here? So 60 into X by 60 plus X, that will be equals to 40 minutes. So 60X, 4 6 are 24 plus 40X. So 20X will be 2400. X will be this 0 cancels, 2 1 times, 2 2 times. So X will be 120. So what is this X? Time taken by tap B alone to fill the tank. Easy, right? If at all you know the formula, if at all you remember the formula, the substitution becomes very much easier here. Okay. The other method is the conventional method. I'll also be solving this in the conventional method here. See, observe here. So what they have given, tap A 60 minutes. So in 1 minute, 1 by 60 part of the work will be done by, or 1 by 60 part of the tank will be filled by tap A alone, right? So they have asked to find out the time for tap B. Also they have given here A plus B when both are open, it takes 40 minutes, right? So in 1 minute, how much work will be done, or how much part of the tank will be filled here? 1 by 40 if both are opened. So we know that 1 by 60th part time taken by pipe A plus 1 by X taken by pipe B will be equals to 1 by 40th part. Yes or no? This is the substitution what you need to know here. Okay, I will solve here. 1 by X will be equals to 1 by 40 minus 1 by 60. So upon taking the LCM will be 120. So 4 3s are, so 3 minus 2, that will be 1 by 120. What is this? 1 by X. Okay, so what is X here? Time taken by pipe B. Okay, so in 1 minute, 1 by 120th part of the tank will be filled by pipe B if at all it's flowing alone, or if at all it's working alone. Okay, so what is the total time taken then? B takes 120 minutes to fill up the whole tank. Okay, so B is 120 minutes. This is the answer here. Option B is the right answer. Moving on to the next question. A cistern can be filled up in 4 hours by an inlet A. A cistern can be filled up in 4 hours by an inlet A. An outlet B can empty the cistern in 8 hours. So an inlet A that is doing positive work here and outlet B is doing negative work here. Okay. If both A and B are opened simultaneously, so then after how much time will the cistern gets filled? Okay. See, I'll be dealing with this in the next page. See friends, what they have given here is A pipe is there. It takes 4 hours to fill up the tank, so positive work. Similarly, pipe B is there, an outlet they have given. It takes 8 hours to empty the tank, so this is the negative work. Yes or no? So net work will be, what it will be? If at all in 1 hour, how much part of the tank will be filled by pipe A? That will be 1 by 4. Similarly, pipe B can empty in 1 hour is 1 by 8. So what is the net work done in 1 hour? So 1 by 4 minus 1 by 8. Got it? So upon taking the LCM, that will be 32. 8 minus 4. 4 upon 32 is the net work done in 1 hour. So 4 1 times, 4 8 times. That will be 1 by 8. What is the net work for 1 hour? What is this net work for 1 hour? Means when pipe A is filling, that is doing the positive work in the tank. Similarly, pipe B is doing negative work, that is the water is draining out from the tank here. So in 1 hour, so 1 by 8 part of the tank will be filled if at all pipe A is doing pipe A is doing the work of filling the tank and pipe B is doing the simultaneously emptying the tank. Okay, 1 by 8 part of the tank will be filled in 1 hour. So total time will be obviously 8 hours. Okay, this is very much easy here. So upon the when you solve it in the formula method, M will be 8 here and N will be 4 here. Okay, this is positive work and this is negative work. Okay, so what is the formula? M into N by M minus N. Similarly, 8 into 4 divided by 8 minus 4, that will be 32 divided by 4, that will be 8 here. Okay, in both methods I have solved the problem here. Okay, it's a simple question. When you know the formula method, in 2 steps only or in the mind only you can calculate here what is M and N. So 8 4s are 32, what 8 minus 4 is 4, so 32 upon 4 is 8. Okay, easily you can arrive to the solution here. So moving on to the next question. Pipes A and B can fill a tank in 5 and 6 hours respectively. Pipes A and B can fill a tank in 5 and 6 hours respectively. Pipe C can fill it in 30 hours. If at all 3 pipes are opened together, then in how much time the tank will be filled? Okay, in the previous video of second point, I have dealt with the 3 pipes problem. If at all 3 pipes are filling up the tank simultaneously, if at all 2 pipes are filling up the tank simultaneously and 1 pipe is draining the tank simultaneously. Okay, I have dealt the formula method there. So if at all you have not watched the previous video of theory part of this pipes and cisterns, I request you to go and watch the previous video. Okay, I'll be solving this question in the next page. So what is the given data here? What is the given data? Pipe A is there, it can fill up in 5 hours. Pipe B is there, it can fill up in 6 hours. And pipe C, it can fill up in 30 hours. So in 1 hour 1 by 5, in 6 hours 1 by 6, in 1 hour 1 by 6 of the tank will be filled, and in 1 hour 1 by 30th part of the tank will be filled by pipe C. This is the basic data what we have got here. Okay, So totally, if at all 3 pipes are simultaneously let open, pipe A, pipe B and pipe C are let open in 1 hour, what is the part of the tank will be filled here? That will be 1 by 6, 1 by 5 plus 1 by 6 plus 1 by 30. Okay, so 30 will be the LCM here. 5 6 are 30, so 6 plus 6 5 are, so 5 plus 1, so 6 plus 6 will be 12 upon 30th part of the tank will be filled in 1 hour if pipe A, B and C are simultaneously let open. Okay, so what you can understand here is 12 by 30 part of tank is filled in 1 hour. What you can understand by this 12 by 30 here, there is 30 parts, in that 12 part is filled up in 1 hour. Okay, so another 12 part will be filled in 1 more hour. So what is the total parts? 24 parts are done. So what is this total parts? 30. So the remaining is 6 parts here. The remaining is 6 parts here. If at all it takes 1 hour to fill the 12 parts, so to fill up the 6 parts, how many hours will be taking? 0.5 hours. So what is the total time taken? That will be 1 plus 1 plus 0.5. That will be total time taken will be 2.5 hours. This is as simple as that. Okay, 2.5 hours is nothing but 5 by 2, or else we also can write it in 1 by 2 hours. Okay, this is one type of doing the problem here. Okay, so in the formula method, how you can be solving this problem here? In formula method, M, N and P here. What is here M, N and P? Pipe A, pipe B and pipe C. 5 hours, 6 hours and 30 hours. So what is the formula here? Formula here is MNP divided by NP plus MP plus MN. Upon substitution, 5 into 6 into 30 whole divided by 6 into 30 plus 5 into 30 plus 5 into 6. This is the substitution here. Okay, 5 6 are 30, 30 into 30 will be 900. That will be divided by 6 3s are 18 plus 5 3s are 15 plus 5 6 are 30 here. Okay, how you will solve it here? 900 divided by 110 plus 150 plus 30, not 110, it's 180. Okay, so 180 plus 150 plus 30 is 360. 900 divided by 360, this 0 cancels. 90 by 360, that will be 2.5 here. Okay, in the formula method we arrived to the solution here. See, one more method I'll be dealing with how to solve the problem here. See, one more method is A pipe is there, B pipe is there and C pipe is there, right? So A takes 5 hours, B takes 6 hours and C takes 30 hours. Okay, see here, observe here, what I'll be doing here is, if at all the time taken is 5 hours, 6 hours and 30 hours, so what is the total capacity I'll be getting here? Capacity is nothing but the capacity of the tank here. Okay, so we need to multiply here. 5 into 6 30, 30 into 30 is 900. Okay, 900 liters is the total capacity of the tank here. Okay, see here, what I'll be doing again here is, so the total capacity is 900. It takes pipe A takes 5 hours to fill up the tank here. Okay, so divided by 5, what I'll be getting? 5 180. So in 1 hour 180 liters will be filled up by pipe A. Okay, similarly 900 divided by pipe B, 6 here. that will be 150. Okay, pipe B will be filling 150 liters in 1 hour. Okay, similarly 900 divided by 30, I'll be getting 30 liters here. Okay, this is about the pipe C here. Okay, so upon adding this 180 plus 150 plus 30, that will be equal to 360 liters per hour when 3 pipes A and B and C are simultaneously let open here. Okay, so what is the total capacity? 900. 900 is the total capacity. In 1 hour 360 liters is filled by pipe A, pipe B plus pipe C. Okay, upon solving this I'll be getting 2.5. So what is this 2.5? The 2.5 is the time taken by pipe A, pipe B, pipe C, if at all they are simultaneously let open. Okay, so friends, here to solve this problem I have discussed 3 different types of the methods. Okay, one is LCM method, and another is the formula method, and another is the upon the capacity method. Okay, so whichever is convenient to you, you kindly adopt that method and try to solve the problems bit more faster so that the time will be reduced for you. So moving on to the next question. There are 2 inlets A and B connected to a tank. 2 inlets A and B connected to a tank. A and B can fill the tank in 16 hours and 10 hours respectively. If both the pipes are opened alternatively for 1 hour starting from A, then how much time will tank take to be filled? What is the time taken for the tank to be filled if at all 2 pipes A and B they are opened alternatively for 1 hour? Okay, I'll be solving it in the next page. What is the given data here? Given data is pipe A, it takes 16 hours. So for 1 hour 1 by 16 part of the tank will be filled here. Pipe B will be taking 10 hours. So in 1 hour 1 by 10 part of the tank will be filled here. But the pipes are not opened simultaneously. That the question is telling that the pipe A and pipe B are opened alternatively. For 1 hour starting from pipe A. Okay, so in 1 hour what is the what part of the tank will be filled here? 1 by 16th part. For the second hour pipe B will be opened, and what part of the tank will be filled here? 1 by 10 part. Upon taking the LCM will be 80. So 5 plus 8, that will be 13 by 80. Okay, so pipe A will be opened for 1 hour, pipe B will be opened for 1 hour. So in total 2 hours 13 by 80 part of the tank will be filled here. What is this 13 by 80? There are 80 parts, so 13 by 80 will be taking 2 hours. Okay, so upon multiplying 13 into 6 I'll be getting 78. Okay, 13 into 6 I'll be getting 78. So for 6 this is interval, for this intervals, these 2 hours is one interval right here. So for 6 that kind of intervals 78 part of the tank will be filled here. So remaining part is 2 part out of the 80 part. Okay, so what is the time taken to fill 78 by 80 part of the tank? For 2 hours of intervals each, 6 intervals is recorded here. So that will be 12 hours. So what is the remaining part? 2 by 80. Okay, and after 12 hours the next in line will be pipe A. Yes or no? Pipe A and pipe B will be working for alternatively starting from pipe A. So after 12th hour the 13th hour will be of pipe A only. So pipe A's efficiency I have got here, right? 1 by 16 part in 1 hour. Okay, what the remaining part here is 2 by 80. Okay, 2 by is nothing but 1 by 40. Okay, So 1 by 40 of the tab, this part should be filled up. This part of the tank should be filled up. So what is the time taken here? It is obviously very much simple here. See, understand here. 1 by 16th part will be filled in 1 hour. That is nothing but 60 minutes. Need to fill 1 by 40 part of the tank in, what is the duration here? Okay, this I need to find. So I'll take it as x here. See, I'll cross multiply here. Okay, x by 16 will be equals to 60 upon 40. This will be cancelled here. So x will be 24 after solving this. Okay, to solve this problem each by step, it takes a lot of time. There is a time constraint, so I need to complete this video. So this all calculations you need to do it yourself. So I'll be writing the final result here. Okay, so total time taken will be 24 minutes. What is this 24 minutes? To fill up the 2 by 80th part of the tank. Okay, so earlier 12 hours was there and 24 minutes has been added here. So total time taken to fill up the tank will be 12 hours and 24 minutes. So this is the solution here. Okay, I will also solve it in alternate method here. See, observe. What is the alternate method here? Pipe A takes 16 hours and pipe B takes 10 hours. So what is the total capacity here? 160 liters of the tank here. Okay, total capacity is 160 liters. So pipe A in 1 hour, how much amount of the tank will be filled here? 1 hour, 160 by 16, that is 10 liters. Okay, so pipe B in 1 hour, 160 by 10, that will be 16 liters. Okay, so in 2 hours, how much amount of the tank will be filled here? 26 liters. 26 liters is the capacity. That part, 26 liter part of the tank will be filled in 2 hours if pipe A and pipe B are opened for alternatively. Okay, for 2 hours we are calculating here, not for 1 hour. This caution you need to take here, right? So what is the total capacity of the tank? 160 liters. Total capacity of the tank is 160 liters. For 2 hours, 26 liters will be filled in the tank. Okay, so 26 into 6, how much I will be getting? 156. 26 into 6 is 156. Okay, this 26, 2 hours. Okay, into 6 I have done here. So 12 hours I will be getting 156 liters of the tank will be filled here. Okay, so what is the total capacity of the tank? 160 liters. So minus 156, the remaining liter is 4 liter. Okay, for 12 hours 156 liters has been filled here. So for 4 liters, what is the time taken to fill up the tank? This is X here. Okay, after completing 12 hours, the next in line will be again the pipe A, right? After completing 12 hours, the next in line will be pipe A, and pipe A's capacity we know, right? In 1 hour it can fill up the tank, that is 10 liters. How much liters we need? 4 liters we need. In 1 hour 10 liters it can fill up. So to fill up the 4 hours, how much time will be taken? 1 hour can be written as 60 minutes, right? So for 60 minutes 10 liters of the tank will be filled, means for 60 minutes 10 liters of the tank can be filled. So for then 1 liter, what is the time taken here? 6 minutes. Similarly for 4 liters, 6 into 4, that will be 24 minutes here. Okay, so upon adding up 12 hours 24 minutes is the answer I will be getting here. 12 hours and 24 minutes. This is the answer here. Okay, so alternate method, for the 2 types of methods I have dealt here. Okay, so upon using the formula method, you kindly solve it yourself and check upon the with the answer. Moving on to the next question. a tap having diameter D can empty a tank in 40 minutes. Okay. How long another tap having diameter 2D take to empty the same tank? Here they are dealing with the volume and surface area. Okay. D is the diameter of the pipe here. Okay. This is the diameter. It can empty a tank in 40 minutes. And another tap having the diameter of 2D, how much time it will take to empty the same tank here. Okay. See, in the next page I will be solving it here. So friends, what is the given data here? Given data is, there is a tap with tap A. Let us consider there is a tap A with diameter D, and it takes 40 minutes to empty the tank. Okay, 40 minutes to empty the tank. So 1/40th part of the tank will be emptied in 1 minute. Yes or no? For per minute, the 1/40th part of the tank will be emptied here. So there is another pipe B with diameter 2D. So what is the time taken here to empty the tank? This is the question here, right? So upon seeing this question, you can see that the diameter initially it was D and it has increased to 2D. Okay, so 2 times the diameter has been increased. So when diameter has been increased 2 times, the area will be increased 4 times. The area will be increased 4 times. See, I will explain with an example here. Okay, if the diameter is D, then radius will be RA. Radius will be D by 2. R will be D by 2, right? So what is the formula for area? Pi R square. So what is R here? D by 2 whole square, right? So if at all we substitute D with 4 here, say for example, pi into D square by 4. D is 4, so 16 by 4. That will be equals to 4 pi. Okay, in the first case. When the diameter has increased twice, okay, in the second case, D will be 2D here. Okay, the diameter has been increased twice here. What is the formula here? Same for area, pi R square. Pi into R. What is R here? 2D by 2. 2D by 2. This will be cancelled here. So D will be 4. So pi upon 16. 16 pi is the area here. Okay, 16 pi is the area. When you see this 2 case, the area has been increased 4 times. 4 into 4, that is 16 here, whereas diameter has increased D to 2D. Okay, so when diameter increases 2 times, the area will be increased 4 times. This is the concept you need to understand first to solve this problem here. Okay, so upon coming back to the problem, A takes 40 minutes to empty the tank. The diameter will be D here. Okay, so in 1 minute, how much part of the tank will be emptied by A? 1/40 here. Okay, so another pipe that has diameter 2D, how much time it will be taking? This will be obviously 4 times more efficient, right? Because area is when the area gets bigger in pipes, the efficiency also will be increased. So 1/40 into 4, that will be 1/10. Okay, 1/10 part of the tank will be emptied by pipe B, which has diameter 2D. Okay, so that is nothing but it takes, the pipe B takes 10 minutes to empty the whole tank. This is very simple problem. Or what you need to know is the area and diameter relationship. Then only you can substitute in the question and you will be arriving to the answer here. Okay, so moving on to the next question. This question is based upon 3 pipes. 3 pipes A, B and C can fill a tank from empty to full in 30 minutes, 20 minutes and 10 minutes respectively. When the tank is empty, all the 3 pipes are opened. Okay, when the tank is empty, all the 3 pipes are opened. A, B and C discharge chemical solutions P, Q, R respectively. What is the proportion of the solution R in the liquid in the tank after 3 minutes. Okay, for 3 minutes simultaneously pipe A, pipe B and pipe C will be opened. Okay, and the time taken by pipe A and pipe B and pipe C is 30 minutes, 20 minutes and 10 minutes respectively. And pipe A, B, C discharges liquid or solutions, chemical solutions P, Q, R respectively. Okay, pipe A discharges chemical solution pipe B, simultaneously pipe B discharges chemical solution Q, and pipe C discharges chemical solution R. Okay, what they have asked is, what is the proportion of the solution R in the liquid in the tank after 3 minutes? What is the proportion of solution R to the proportion to the whole liquid after 3 minutes of all the tanks all the pipes have been let open. Okay, so I will be solving the next page here. So friends, what is the given data here? The given data here is pipe A takes 30 minutes, right, to fill up the tank. So in 1 minute, 1/30th part of the tank will be filled in 1 minute per minute. Yes or no? Similarly, pipe B 20 minutes. So that will be 1/20th. And pipe C will be 10 minutes. And that is 1/10. Okay, this you need to write basically. So what is the LCM here? 1/30, 1/20, 1/10. So if at all the pipes, pipe A and pipe B and pipe C are let open for 1 minute, that is nothing but 1/30 plus 1/20 plus 1/10. So what is the LCM here? 30, 20 and 10. The LCM will be 60. 2 plus 3 plus 6. This is the LCM here. So 2 plus 3 plus 6 is 6. 11/60 part of the tank will be filled in 1 minute. In 1 minute. 11/60th part of the tank will be filled in 1 minute if at all the pipes A, B and C are left open for 1 minute. So this is the first step what you need to do. So for 1 minute is 11/60, and the question tells us for 3 minutes. For 3 minutes the pipes are open. So 11/60 into 3, that will be 11/20. 3 1 times, 3 2 times. Okay. So for 3 minutes 11/20 part of the tank will be filled. For 3 minutes. Okay. And we also know that part filled by C in 3 minutes will be, so part filled by C in 1 minute, what we have know is 1/10 here. Okay. For 3 minutes, that will be 3/10. For 3 minutes, part filled by pipe C in 3 minutes will be 3/10. So they have asked the ratio of inlet C upon total liquid, right? They have asked the ratio. So what is the required ratio here? Required ratio will be 3/10. This is by part C upon 20/11. In 3 minutes all the pipes will be discharging this amount, 20/11 amount of liquid, and pipe C will be discharging 3/10 amount of the liquid in 3 minutes. Okay. Upon cross multiplying, I will be getting 6/11 here. This is the solution. So option B is the right answer for this. Option B is the right answer for this. So moving on to the next question. A pipe can fill the cistern in 12 minutes. A pipe can fill the cistern in 12 minutes and another pipe can fill it in 15 minutes. But a third pipe can empty it in 6 minutes. The first two pipes are kept open for 5 minutes in the beginning, and then the third pipe is also opened. So time taken to empty the cistern is, okay. So here two pipes are doing the positive work and one pipe is doing for negative work. In the first instance we will get to know by reading the question, two pipes are doing positive work and one pipe is doing negative work. But the time difference here is, the first two pipes which are doing positive work, they are kept for 5 minutes open. then the pipe which is doing negative work is opened here. Okay, so then what is the time taken to empty the cistern? 38, 22, 42 and 45 are the options. I'll be solving it in the next page here. So friends, what is the given data here? Given data is pipe A takes 12 minutes, right? And pipe B takes 15 minutes. 15 minutes. And pipe C, it takes 6 minutes. This is doing negative work here, and the other two are doing positive work here. The other two are doing positive work, and the pipe C is doing negative work here. Okay, this can be solved upon both formula method and also the conventional method. See, one more method I'll be dealing here. Try to understand this, and the various methods I have dealt in previous problem, try to use those methods as well as formula methods for your convenience sake. Okay, the another method is based upon the efficiency here. Okay, see here, I'll be dealing with the efficiency method through which you can solve the problems here. Okay, we have written the given data here. A is 12 minutes, B is 15 minutes and C is 16 minutes, whereas C is the negative work done here. Okay, when you take the LCM of all these three variables, that is LCM of 12, 15 and 6, what I'll be getting here is 3 4s are 3 5s are 3 2s are and 2 2s are 5 2 1s are 2 1 times 5, so 5 1 times. Okay, 5 2s are 10, 10 2s are 20, 23s are 60. So LCM is 60 here, right? So total work will be 60 here. So efficiency of pipe A, how I will be calculating here is efficiency of pipe A, that will be equal to total work 60 divided by what work it can do, 12 minutes. Okay, that will be equals to efficiency is 5 here. So similarly, efficiency of pipe B will be 60 upon 15, that will be 4. Okay, pipe A and pipe B, these are doing positive work here, kindly understand. And efficiency of pipe C will be 60 upon 6, that is 10, and this is doing negative work here. So till here you got the problem, right? The method I am solving, I am trying to find the efficiency here. Okay, so we also know that formula, that is time into efficiency is work. Okay, time into efficiency is work. Therefore efficiency of C will be negative as it is an outlet pipe. Okay, this is an outlet pipe, so hence the efficiency of C will be negative. So the question says that A and B are opened for 5 minutes. A and B are opened for 5 minutes. Okay, so what is the efficiency here? A plus B, 5 plus 4, that is 9 here. Okay, 5 plus 4, how I got here? This is 5 and this is 4. So A plus B, 5 plus 4, that is efficiency of that is the efficiency of both the pipes here. Okay, not the efficiency, actually the work done. See, so for how many minutes they have opened the pipe here? So for 5 minutes. Okay, 9 into 5, so 45 parts of the work will be done for 5 minutes, that is 45. 9 into 5 is 45. Okay, what is the total efficiency of all the pipes? A plus B plus C, these two are positive, A and B are positive while C is negative. Okay, if 5 plus 4 minus 6, that will be efficiency will be net minus 1. Okay, so total amount of work done in by A plus B pipes is 45 minutes, and the total efficiency after 5 minutes will be minus 1. So what you get to understand by seeing these two? For the first 5 minutes, okay, for the first 5 minutes 45 parts of the tank will be filled. So after 5th minute the efficiency will be minus 1, right? So to empty this 45 parts, how many minutes it will be taking? For every minute the efficiency is reducing by 1 part, right? So that is 45 minutes it will be taking to empty the tank. This is the answer for this. Okay, also try to solve it in the formula method, which I have mentioned in the previous video. Okay, the same type of problem I have mentioned in the previous video. I have taken the example, and what is the formula to be applied upon, I have told you. This is the new method in efficiency method, not the new method actually. This is another method, another conventional method to solve this problem. I have explained to it to the efficiency method. Okay, so moving on to the next question. The next question is based upon passage here. Bank credit to the industrial sector has started shrinking. Bank credit to the industrial sector has started shrinking. Its decline has been a serious concern as credit growth is essential to revive the investment. Okay, so they are talking about the bank credit to the industrial sector, and it's shrinking, and to revive the industrial sector or to revive the investment, the credit growth should be more. The problem's origin lie in the incomplete reforms of the last 25 years. Okay, so why this problem originated in the first sense? Because about the incomplete reforms since 25 years. Okay, an institutional change that should have followed the 1991 reform should have been setting up a resolution corporation for banks. Okay, this is very important here. An institutional change that should have followed the 1991 reform should have been setting up of a resolution corporation for banks, because this is the problem in the first two sentences what they have given here. Okay, this is the problem situation, and what might be the possible solution for that? An institutional change should have been followed. Okay, since 1991 reforms, this is the possible answer for the problem there. Okay, in a market economy with booms and busts, bank should be allowed to set up and fail. Okay, today we cannot shut down banks because there is not proper system to shut them down. Weak loss making banks continue, need to more capital. Okay, they are talking about the problem here. What is the problem? That is the problem of bank credit to the industrial sector in the first two lines. Okay, there is a problem to the industrial sector. It's not growing up sufficiently, as the credit growth is very much less here. Okay, to the industrial sector. So why this problem has been originated? It is because of the incomplete reforms in the last 25 years. Okay, so to revive this, what is the possible solution? In the third line it's offering, right, an institutional change that should have followed the 1991 reforms should have been setting up a resolution corporation for banks. Okay, so for banks, there need to be set up a resolution corporations on the based upon 1991 reforms. This is the possible solution for the above situation, right? Okay, and also it states that in a market economy where with booms and busts, bank should be allowed to set up and fail. Okay, bank should not be controlled, it should be allowed to set up and fail. Today we can shut down banks because there is not proper system to shut down bank. See, once the bank has been established, there are no proper rules and regulations, or if at all in a whole way we can say that in a market economy the bank should allow to function itself. Okay, there should not be any regulations like it. See, the banks need to only lend to agriculture sector, or only lend to industrial sector, or only lend with lesser percentage of interest. These kind of things should not be regulated. In the last two sentences of the passages, what we can infer here. Okay, so what is the question here? Which one of the following is the most logical and rational inference here? Okay, the question is talking about the inference here. So in the previous videos I have told you that what do you mean by inference here? Inference is nothing but it's a piece of information, right? An inference, it can be a piece of information which can be logically deducted. Okay, which can be logically deducted from the given passage, from the what the passage states. From those information, the inference can be logically deducted. Okay, see here, we'll check out the options here. Indian banking system is not able to help the country in its economic growth. See, this is not the rational inference what we can get from reading the passages. Indian banking system is not able to help. This is the wrong here. Okay, economic reforms that started in 1991 have not helped in improving the economy to the expected levels. Okay, nowhere in the passage it states that economic reforms started since 1991 have not helped in the improving the economy to the expected levels. The in the passage they have given to the reforms since 1991. Okay, based on that reforms, the bank reforms need to be taken. The that kind of statement have been said in the passages, not about the not helping the improving the economy to the expected levels. Okay, so what is the third statement here? India lacks the institutional mechanisms to deal with the failure. This is the most logical statement till this option. Okay, so I'll also check the fourth option. Encouraging the foreign investments in our industrial sector is a good alternative to this sector dependence on banks for credit. See, they are talking about the less credit for banks here, but the passage nowhere in the passage we can bring about the conclusion that foreign investment should be made to the bank so that it can help to the industrial sector, right? Nowhere in the passage it's been talking about the foreign investment. See, upon examining all the four statements, the C statement stands absolutely right here. India lacks the institutional mechanism to deal with the failure of the banks here. Okay, so C is the most logical inference or rational inference that can be made out to this passage here. So moving on to the next question. India has tremendous potential for solar energy. We all realize that we have to stop burning fossil fuels to meet our energy needs. But certain renewable sources are still growing through their cost curves and learning curves to get the required amount of the output. Okay, the Indian government has strongly committed to its targets of reducing emissions by 33% by 2030, and towards this it has initiated a strong push towards the gas based economy and has also invested heavily in renewable energy. However, business houses are wary of investing too heavily in renewable energy at a time when the technology is not yet ready. Okay, so what's the passage talking about in the first part? India has tremendous potential for solar energy. There is a tremendous potential for solar energy. So there is a tremendous potential for solar energy. We all realize that we have to stop burning fossil fuels to meet our energy needs. But certain renewable sources are still going through their cost curves and learning curves to get the required amount of output. Okay, so we have tremendous potential of solar energy, but certain renewable resources, okay, are still going through their cost curves and learning curves. They are still in the initial stage of development to get the required amount of output. Okay, this is the inference we can assume from the we can infer through the third statement here. The India government has strongly committed to its targets of reducing emissions by 33% by 2030, and towards it has initiated a strong push towards a gas-based economy. Okay, it has already strongly committed to reduce the emissions by 33%, and to achieve this, it has initiated a strong push towards the gas-based economy and also invested heavily in renewable energy. However, business houses are wary of investing too heavily in the renewable energy at a time when the technology is not yet ready. So what you can infer is technology is not yet ready, but it is in the developing stage. It is in the initial stage. Hence, it is taking a lot of investments, and also the government is committed to reducing the emissions by 33%. So it has initiated strong push towards a gas-based economy, as also simultaneously it has also heavily invested in the renewable sources of energy. So what is the question here? Which one of the following is the most logical and rational inference that can be made from the above passage? Okay, it's a most logical and rational inference. Okay, India's commitment to reduce emission by 33% is unlikely to be achieved. No, this is the wrong assumption, because India has committed to reduce emission by 33%, and to achieve that it has been investing in renewable energy as well as the gas based economy. Okay, so first statement is wrong here. India should import gas rather than invest in nowhere in the passage it is speaking about the importing gas from any other foreign countries so that the investment can be reduced here. Okay, the passage is talking about the investments have been heavily made in renewable energy, and still it has been in the initial stage, so it is taking up a lot of money here. Okay, we'll be checking option C here. Getting renewable resources to market too soon may be costly. Okay, this is the most probable assumption we can make here. Okay, getting renewable sources to market too soon may be costly because the technology is in the initial stage and it is taking up lot of investments. And also in the last part it is saying that businesses, houses are wary of investing too heavily in the renewable energy at a time when technology is not yet ready. Okay, getting renewable resources to the market too soon means when technology is not yet ready, may be costly. Okay, it is the most probable option. I'll be checking also option D. India should put in more efforts in the exploration of natural gas. Nowhere in the passage it is talking about the exploration, so hence option C is the right answer here. Okay, moving on to the next question. With reference to the above passage, the following assumptions have been made. In the previous questions, we had talked about the inference. In the this question, it is talking about assumptions here. Okay. So what do you mean by assumption here? An assumption is nothing but an hidden or unstated premise. Okay. There is not direct saying of that assumption because its meaning is hidden in the passage here. Okay. See here, I'll be checking out the statements here and I'll tell you how we can arrive to the answer here. Government often provide inefficient and costly subsidies for technologies that may not be ready in near future. Okay, with reference to the above passage, the following no assumptions can be made here. Okay, governments often provide inefficient. See, often provide, it is telling government may provide. No, it's not telling like that. Often provide. So this is wrong here. Governments often provide inefficient and costly subsidies for technologies that may not be ready in the near future. So this is wrong here. India's commitment of reducing emissions by 33% by 2030 shall be on the basis of gas-based economy. On the basis of gas-based economy. No, it's also based upon the investment done on renewable sources. Okay, not only on the basis of gas-based economy. So this also can be striked out. Okay, following assumptions can be made means this assumption also can be striked out because they are talking about the gas-based economy to reduce the emission by 33%, because they are also in the passage they are also telling that it has been made through renewable energy. It is trying to achieve through renewable energy by making heavy investments in the renewable sector. So which of the above assumptions are valid? Neither one nor two is the right option here. Okay, neither one nor two. Okay.